So today we are going to talk about the problem class lecture 2, the correlation and convolution. So let's firstly talk about some basic concepts. The correlation is between some kind of relationship or similarity between. Maybe cross correlation is between the X signal and the Y signal, and the autocorrelation is because finding itself. For example, you can see the stock of the price going up and down, and some kind of pattern is not that obvious, and we can use autocorrelation to find the similarity between himself, whether this kind of signal is repeating himself. Okay. And the convolution just means that the system response for the signal. It's kind of the system feedback to the system, and we will learn that later in the class. I mean, I'm not very sure what are the meaning for the system response. I will ask them on the blackboard. What is exactly the system response? I mean, I know I kind of discussion board, and let's create a trend. What is the meaning of the system response? What is the meaning of the convolution? I cannot. You mention. Can be described as a system response. Can you help me out? So this is my first question, okay, and okay, cool, and let's let's look at some. Look at whether there are some trend here. There will be a table for the G transform, the transform, sub transform, some triangle diagonal. No formula sheet. So it will only be tables. Okay, cool. And this question asks, I think section A doesn't meet the requirement of the Casio signal. So, which of the following is non-Casio signal? So xt is less than 0 for t. T is less than 0. That does not count. I mean, it should be t is 0. It may apply to a non-Casio, but does not describe a non-Casio. Cannot be. However, I will upload the mark scheme to allow 25 who choose that option. As all, I see. So that one may be true. I mean, which of the following characterize a non-Casio? I mean, non-Casio here means it can be I mean causal means that it is 0 when t is less than 0, and so what if t is less than, I mean it may be true, but the xt is less than 0. I think it is true, right? Xt is less than 0 for t not equals to 0. It is true that the first condition in the may apply to, but it does not characterize. Why? I mean, xt is less than 0. Or characterize. Oh, I see. So this is kind of language matter. So the key thing is characterize. I mean, this is a much more smaller condition, but it can infer to that it is not a causal signal. But what if, I mean, xt is greater than 0? It also applies. So therefore, we cannot use Zeta statement to formulate this. So the final exam does not contain any multi-choice. The promo sheet are meant to help you to learn the multiple choice format that help you to, for some people, it helps you to. Okay, cool. So, final exam does not have the multiple choice. So there is no stream for some lectures. So this module is a problem-based learning where you can solve from rather than attending lectures or like PowerPoint. If you need help, we can use of the home class and I. The natural is in practice to learn or listen to lecture. Cool. Formula sheets. This is done. Our elementary functions. Continuous step does not need to be defined. There is no question where there is an issue. Yeah, right. U0 is. That's not. U0 is 1. So this question means that so this is very interesting, right? Let's look at that. This one is passé, right? Passé. I think it should be a little different about at the point of if you in the discrete, that is to say, but it's going to be different because in the manual case ut when t takes 1 but this takes it can only take 1. So I think yeah, right, yeah. I agree with the either power signal or energy signal. It is cool. 我说一句酷。这个单调递增的，就是它既不是增的，也不是，好像没啥。Let's add another question. I mean, what if two signal periodic signal with T1 and T2 as their x t with x t with T1 and y t with T2. What will x t times y t be so I really want to ask, what about the signal times another signal where the so let's talk more about this. We ask what is the meaning for the convolution, right? Okay. So let's look at that. So this one, okay. Another thing I want to mention here is the delta Clark function. It is the reason why we use that because you remember that you need to see a thing that look. Let me tell you a thing that you remember this function, right? You remember this function. So this function is only when x equals to t equals to a, right? And the area here is 1. Okay. So the area here is 1. So and you can imagine, what if the xt times this signal? It will only be, and the integration for that one is 1, and for every other thing is 0, and it is 1 times the value of the signal. It is 1 times the value of the signal, and you can find it is 1 times the value of the signal, so the final result will be xa. So that is based on the property of Dirac function, we can, as long as we have seen this, we can use xa to solve that. We don't want to solve the integration. And the cross correlation here is, the correlation has been mentioned, and I will have further question about the convolution, which will be introduced in the next lecture. So let's talk about that one. So that one we mentioned that it's going to be cosine. This one going to be at 0. So it is cosine 0, it is 1. And this one is going to be cosine pi, is going to be -1. Since cosine pi is -1. And this one here is that t equals to -2 pi is going to be minus pi, and it's going to be 0. So this one is going to be 3 times 1 plus 1 is going to be 4, and this one going to be -1. And just remember, where does the variable within, where does the variable within this square to be the 0? Okay. So this one t equals 3 to the power 3 minus 1 is going to be that is very important. Let's look at that. Okay, let's look at that. So why do we must care whether we must care what are the lower bound and upper bound in this one. So for example, you can see, so this is t equals to 0, and it is within the lower bound, so we can plug t equals to 0 to this one. However, this one t equals to 3, but it is outside of the bound, which is -1 and +1. So therefore the integration should be 0. That is very important. We must check the lower bound and upper bound of the signal to see whether it matches the condition. So since it's minus, and we can see that it's going to be t equals to 1 plus cosine t. Cosine pi is going to be -1, so going to be 0. And we see that it's going to be, you found this one. Okay, this one is very, let's deal with that. So this one is going to be -1, right? And ut is 左加右减，左加嘛，然后 ut 是这样，就是这是0嘛，所以它这个信号是这样的嘛，对吧？ 那它这个信号是这样的，你就会发现一个很神奇的事情，它这边全是0，就相当于这个自相残杀掉了，对，所以说这个信号这俩一乘就成了个0啊，这个是个0信号，这个0信号呢乘以啥，反正都是0，所以说你就不用管了啊。然后 simply by removing the step function, you will get the limit for the integration. So this one is just to change this one. So what if it ut is going to be 0 infinity xt dt? Okay. So the reason is that the unit step, this one will always be 0, so it is no meaning talking about that. So going to be that, and so this one does not have some. It's just changing the 2 pi and minus infinity and xt dt. Yeah, that is. And additionally, let's look at that one. So this one is, real number is minus t. Okay, so this one is going to be minus a 无穷 xt dt. Okay, cool. That is that. And in terms of that one, so that one is very interesting. So that one is this one. So this one going to be minus infinity to 0 xt dt. Yes, that's it. And then this one is going to be since it is like that 4, therefore it is minus infinity 4 xt dt. Yes, that is. Yeah, and then this one is going to be, this one is very important. Let's look at that. So it is xt times ut minus 4 minus t dt. So this one, let's look at that. So ut is like that, okay, and ut minus t is like that. So this is going to be like that. So this one is going to be, the signal might be 0 to 4 xt dt, right? Exactly, right? dt. Okay, so look at that one. Okay, that one is really interesting. It's just changing changing the b to t here. So how to think about that? So the ut is here, right? And this one must be t, and this one must be b, right? And this is 0. So this is going to be a times 0 to, oh no, I remember that. So what if the b is greater than 0? Greater than 0? What if it is 0? It is 0, right? So what if b is greater or equal than 0? It is going to be e dt, so it's going to be ab. And what if b is less than 0? So it is going to be 0 because there is nothing to integrate here, right? So let's continue to talk about that. So which of the following is true about the convolution? It is very important. Do not just simply take the b, okay, as granted, okay? So let's continue to talk about. So which of the following is true about the convolution operation? Okay, convolution. So remember, this is a linear operation. So this is linear, this is also linear, this is also linear of true. So it's going to be D. Okay. So which of the following statement is not true about the delta Dirac function, unit impulse? So which of the following is not true about the delta Dirac function? That is very. So the delta Dirac function, that is very interesting. The delta Dirac function. Let's look at that. So, it's not true, right? It's not true. So delta Dirac function is like that, right? You can see delta Dirac like that. So what if the, this is true, right? Because, this is 0. And ut is infinity. It's definitely infinity. And ut is equal to the integral of the, yeah, right. What if it's less than 0? It is 0, right? And then it is also true. If greater than 0, since the error here is always 1, and that is the the unit step function. And what if ut when t is not equal to 0, right? This is also true because this is 0, this is, and ut is equal 1 here, so this is going to be a2, so it's not true, so it is f, right? This one going to be f. The question 4 going to be f, and this one going to be a. This one going to be d. So this one going to be D. Yeah, it's going to be D, right? So then we are going to talk about what is the convolution of E minus AT, UT, and UT. So what is the convolution? Okay, let's do the convolution here. Firstly, let's remember the formula for the convolution. The formula for the convolution is here, right? So let's how about, oh, it's not this. I think it's this, right?啊，不是这个呀。哎，我要的是copy。然后我们把它 place 到这里。哦 ，no， that's so let's do that, okay? So what is the convolution for that? 我记一下是 xt 卷积 yt 等于负无穷到正无穷x 反正是 d 涛x 涛 y t 减涛，是吧？t 减涛减 t 啊，这是涛吧 ？x 到 y t 减涛，没问题啊，没问题。哎，不要怕啊！好，来做这个东西呢，它就等于这个负无穷、正无穷，这个 e 的负，哎呦，别急。我不要它下去。哎，我操，还牛逼的呀！我要让你下去。哦，这是一个功能，没事，继续啊。那你看这个 x 涛应该是多少呢？它这个 x 涛是不是 e 的？哎呦，我操，牛逼的！这不是 e 的负 at ut 吗 ？y 是不是相当于 u 的 t 减涛啊？然后 d 涛，好，再看啊，你这个 ut，你这是不是 t 对吧 ？t 你是不是你要把 t 换成涛对吧？你现在是 x 涛嘛对吧？你现在最后是要变成涛，所以说你这个东西嘛，就是把这里你既然这有个涛，所以说你把这个就是0到无穷，对吧 ？e 的负 at u 的 t 减涛 d 涛。好，看到这个 t 减涛了没有？所以它就变成了这个，因为 t 现在就是未知数嘛，所以说就变成了这个0，因为 t 是大于0的，好像 t 会不会说大于0 ？t 应该是大于t 也没有说 t 大于0，所以说现在我也不敢说。那么这个 t 我先假设，如果是 t 大于0的情况下， 这个 t 大于0，如果 t 大于0呢 ，t 小于0的话，它是不是就是0，对吧 ？t 大于0，对 ，t 小于0它就是0。但是那个 t 小于0的话，它就是 t 小于0，它就是最后就是0。如果是 t 大于0的话，它就变成了这个 t e 的负 a t d 涛。所以这个东西呢，就那个，如果它是就上界减下界嘛，就是 e 的负，哎，不对呀，它不是无穷吗？无穷不是 t 减涛 t 了吗？对啊，那个，哦，sorry，不好意思，就是它这个东西啊，它是那个，就是 e 的负 a t 是个长值，所以说如果它大于0的话，那它就是一个 e 的负 a t， 然后再乘一个 t。如果小于0的话，它就是一个这个，如果它小于0的话，它就是一个这个，这应该是 b 吧？我怎么感觉？哦，对不起，这个是涛，抱歉，不好意思，这个是涛，就是这个地方呢，它应该是个涛，对吧？这也是个涛，所以说它应该是个负1比 a 在前面，然后呢，这个是 t， 这个 t 减0，t 减1，别急，就是这个情况有点糟糕，这样啊，咱们这样来看，我先把这个都擦掉吧，这样我把这个都擦掉。So this is going to be deleted, right? Okay. So let's look at that. Okay. So okay, cool. And let's look at that. Okay. I think I can write that. So this is minus infinity to infinity. Okay, minus infinity to infinity. X tau is going to be e tau u tau, right? So x tau, and ut is going to be u t 减 tau d tau. Okay, cool. So what else? Okay. So look at this tau. So this tau can change the magnitude to be this one to be 0, right? So this one going to be 0. So this one is 0, and additionally we're going to see that this tau is going to be disappear, right? And what if we time this together? We will see. You remember this question that what if t is less than 0? It is going to be 0, and t is less than 0 is going to be 0. And what if t is greater than t is greater than t is greater than 0, it's going to be that. Okay. So the key thing here is what if t is greater than 0, it is going to be this one. You're going to change it to t, right? So this one going to be t. So we have to look at that. So that is t, right? It's going to be t. This is going to be t. So look at that. If this is going to be minus and going to be e minus at minus 1, right? So the final result should be that. So look at that. It's ut t that is 0, and 1 minus e This is just to change this sign to, yeah, that's that. So the final result should be A, right? Right. Yeah, only if t is greater than 0, so it can be changed. So every time we write the what if it, only if t is greater than 0, it is going to be 一减 e 的负 a t ut. That's exactly the same, right? So that is pretty much it, and thank you very much.